Hello again, we're going to be continuing with today's video lesson, which is on exponential graphs. You'll find this on page 130 of the textbook. So as usual, our methodology for unpacking these types of graphs is to start off with the simplest case and then adjust variables, change axes, and see how this affects the overall shape of the graph. So our simplest case will be y equals 2 to the power of x. Our notation for exponents tells us this 2 is called the base and the x is the power. So I'm going to make up some x values and then plot this for x and y, and I'm going to go -2, -1, 0, 1, 2, 3. Okay, now we're going to substitute each of these x values into the equation to get the y values. So for x equals -2, we have a y value of 2 to the -2. And our rules for exponents tell us that we need to flip it and change the sign of the power. So we flipped it and it went from -2 to +2. So this comes out to 1/4. For the next point, we have 2 to the power of -1 as our y value, and our rule is we flip it and change the sign of the power. So it goes from -1 to +1, and this comes out to a half. The next point is easy. Any number to the power of 0 is 1. So 2 to the power of 0 is 1. Next point is also easy. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. Okay, let's plot these points. -1, -2, 1, 2, 3, x, y. So I'm going to make my vertical axis go up in 2s because our y values go all the way up to 8. So I'm going to make it 2, 4, 6, 8. 4, 8. So in between 0 and 2 is 1, in between 0 and 1 is a half, and in between 0 and a half is a quarter. So that would correspond to our first point, -2/4. Next, -1/2, 0, 1, 1, 2, 2, 4, and 3, 8. So our graph would look something like this. Okay, so you can see that this graph rises very rapidly. In fact, its rate of increase is faster than that of a parabola. And it represents exponential growth. You might have heard this term before. For example, a newborn baby grows exponentially. It grows on its previous growth, starting from a very small size, and it grows very rapidly. It would also learn very rapidly, learning off previous knowledge. Exponential growth can also be used to describe rapid spreads. So, for example, the spread of a virus. That describes this portion. What is happening as x gets negative? So we can see that as x gets more and more negative, it looks like we have a horizontal asymptote along the x-axis. So let's just check that with some numbers. Let's put in some fractions. So we're going to make x more and more negative. So it's going to be 2 to the -1, 2 to the -2, 2 to the -10, 2 to the -100. X is getting more and more negative. Let's see what's happening with the y values. So as a fraction, this would be a half. This would be 1 over 2 squared, 1 over 2 to the power of 10, 1 over 2 to the power of 100. So we have fractions in each of these cases, and our denominator is getting greater and greater. When the denominator of a fraction gets greater, we're dividing by something which is bigger, so the overall fraction gets smaller. So as x is getting more and more negative, the y values are also shrinking. So when fractions are getting smaller and smaller, it's still positive, but decreasing. So that explains this tail. And indeed, we do have a horizontal asymptote along the x-axis. So now we're going to change a few of these parameters and see how it influences the shape of the graph.